Hello, everyone. We are now live with the AI for Hospitals workshop that I have prepared with AI for Health and our amazing speakers today. The goal of this workshop stems directly from our moonshot sessions that we had just an hour ago with all our amazing speakers, and also from our barometer of the adoption of AI in hospitals. The goal here is that in 2020, we carried out the barometer of AI adoption in hospitals in Belgium and figured out that the vast majority of the 98% of Belgian hospitals that participated in our barometer are very enthusiastic about the AI as a very positive development within the health field, but AI is not perceived as a structural, strategical objective within hospital environments. And this is why today we are gathering up with people from hospital management teams to think about and inspire you about what AI can do within hospitals. And for this, we have gathered amazing speakers today that I will introduce one by one for their own specific topic. Okay, so let us start with a brief topic about what the AI for Health revolution is and why it is important. And I'm happy to show this to you. As a start, I see that we have our colleague Bart Collet that has joined us within the audience. Bart from Health Scouts has prepared a very nice document called What AI Can Do for Your Hospital. And I'm sure he will share the link within the chat so that you can access this practical document on what AI can do for your hospital. I will cover the main domains, but if you need a very nice infographic, you can access that document right online on the Health Scouts website. Okay, so why is AI important? Why is AI important in the health domain, and why do we need to embrace this revolution? Well, within AI for Health, we are sure that AI can do 5 main goals for health. The first is to make the population healthier and improve the quality of care. That is, we can use AI tools to better detect, diagnose, monitor diseases so that we can better follow up patients and make citizens more healthy. The second part is that AI can augment the skills and quality of life that healthcare professionals do have. We do know that the healthcare environment is not an easy one to work within because there are many, many challenges. And we have seen that with the pandemic. Now, we know that AI tools can help healthcare professionals have an easier life. And we will talk about that today. The third objective is to support healthcare organizations. We do know that hospitals do struggle nowadays, but AI tools can help us improve the way we provide care and support the organizations that do perform the healthcare. The fourth is to stimulate the research and development so that we can better take care of patients in the future with new drugs, new procedures, and so on. And finally, the fifth aim is to drive public health policies. We know that we should have used more AI, as some countries have done it during the pandemic, to better predict several things. But we now know that AI can be big in predicting what's coming next. So how do we do it? And why is AI the right tool to do it? Of course, AI is just one domain for digital health, but AI has mainly 4 methods of achieving this. Well, first, AI can help us studying the individual along with the collective. We can use ideographic research methods that belong to the individual to study repeatedly measures that belong to the individual, such as parameters, such as behaviors, such as other symptoms that we can gather and study how the patient evolves over time so that we can better monitor him. The second is that we can gather the whole, and with genomics and the other omics, we can gather the whole of each citizen so that we are able to provide with a personalized care. The third is improving the adherence. That is, we know that patients, when they're left alone, they live their own life and they may adhere or not to a treatment. Of course, passive data collection can help us better take care of patients where they are not in front of us as doctors. So we can better monitor them and provide them with better care options. And fourth, with AI, we can connect the dots. We can connect the dots. That means dealing with causality, dealing with connections among different components of diseases so that we can get better insight and better treat patients. The domains of the new healthcare, thanks to the AI revolution, the cognitive revolutions, are several. Here are 8 of them that are main domains. First, there's monitoring. Of course, we know that checking up on a patient is something that we generally do at the hospital or when we have the patient in front of us as healthcare professionals. Of course, monitoring nowadays can be done at home for the patient while we monitor for their heart, for their diabetes, for their epilepsy, for many, many diseases and other parameters that we can check up on and see that if the patient does not go wrong, but also to improve the overall health of the patient. Second, we have diagnosis. We know that AI is very helpful in diagnosing pathologies, and diseases can be better detected when using AI software. For instance, radiology, that we will talk about today with Frédéric Lambrechts, pathology, that is laboratory medicine, that we can better detect diseases based on human samples. Third, we can better predict a risk of a given disease based on each patient record with clinical decision support system, for instance. Fourth, we can improve prevention, that is, monitor patients decades before they are even susceptible of developing a given disease so that we know that we can provide them with the best care possible. Fifth, we know that platforms allow us to recruit patients for digital trials and provide data. After that, we know that clinical intelligence is a big part for hospitals. We can guide doctors into making decisions and to better take care of the administrative environment around them. After that, we know that we have tools that we have to augment humans, such as prostheses, such as cell therapeutics, and so on. And so we know that we can improve the way we do care with tools that we never imagined before, thanks to AI and data science. And last, this is kind of important to me, is to reduce the administrative burden. We as doctors and as healthcare professionals want to care for patients without the administrative burdens that comes with, because when we do have less administrative burden, we are better carers for our patients. And this can be achieved through different technologies. Making the revolution possible requires 4 main pillars, the first of which are data environments. We know that we need an inter-system communication to allow for primary and secondary use of health data so that we can use the data when we need it for patient care, but also develop other strategies around the data and take care of administrative tasks and so on. We also know that we need to connect our own systems within the hospitals with the continuum at home for the patient. We know that we need to create a care home continuum between hospitals and care institutions and patients' homes. That is, we need to avoid the loss of information and being able to plan ahead. And for me, this is especially important with the link between nursing homes and healthcare institutions, such as hospitals. Third, we know that we need ecosystem interactions. Many hospitals have dozens, hundreds of apps that participate in the collective IT infrastructure of the hospital, but they do not communicate within each other. We know that we need to we now need ecosystems that take care of several dozen tasks instead of specific apps that each deal with a specific thing. And finally, we need to include the citizens and the patients to the way we innovate with these digital technologies, so we can raise awareness and help them participate in our revolution. Okay, all of this is amazing, but can we be there yet? And of course, healthcare professionals and institutions are ready for the revolution. We have seen that with the AI for Health barometer that we published last year. We know that national and European strategies are taking shape, and we are gaining patient trust, as several studies mentioned them. Patients are okay with sharing their data as long as they know what is being done with the data and as long as it can help healthcare professionals. In the meanwhile, while all these big things are coming into motion, what we can do is have some quick wins. And these are things that every hospital can do nowadays. And one has to really know their own hospital environment to better know what we can do with it as a quick win. We can improve the remote care with medical devices. We can retrieve the previous data that has been collected in the past years. We know that we have that. And we need to mine nomothetic insight, that is population level insight, to make some general models of what is happening with our healthcare system. Of course, medical devices have a big part to play in the cognitive revolution. We know that we need to extract data thanks to the medical devices so that we can define what the omics domain resembles to when we deal with patients. That is, if we have medical devices that can collect several parameters, we have that many dimensions that we can collect within each individual, and that many dimensions that can participate into personalized medicine. Interactions with real and digital environments, of course, clinical and related part is a necessary step of adopting medical devices. Prediction and monitoring is a added value of many medical devices. We can predict that a given episode is occurring within patients, and so we need to take care of the patients immediately. Patients' education can be achieved with medical devices and digital therapeutics, for instance. But also, one of the main challenges in dealing with medical devices is the signal processing and the false positive management. Our hospital teams need not be alerted every time there is a false positive, and so false positive management is a big thing when dealing with these parts. Education is key, as I mentioned, and so we need to educate patients in the realm of the digital. We need to educate doctors that are used to deal with their job 24/7 from A to Z themselves, but some parts can be extracted and be taken care of with the machines. Other healthcare professionals, such as nurses, such as physiotherapists, ergotherapists, and so on, psychologists can take full advantage of digital apps and digital technologies so that they can better take care of patients. But also research teams and institutions can merge within hospital environments to provide new ways of caring. The challenges of adoptions are quite a number of them. Nowadays, each hospital with current reimbursement strategies will ask themselves, is this app or is this technology going to be a cost for me, or is it going to be an investment? Will I be able to be a more performant institution while adopting this technology? So getting one's priorities straight is a big challenge within each hospital and each institution. Evaluating a model that is used and involves AI and involving its quality is a major step. Of course, gathering evidence that a model actually improves care is a big thing of what we need to do. Coordinating with international goals and self-regulation, is one of the macro objectives of what we need to solve for adopting easily AI in our ecosystems. Also, having indirect added value for organizations such as research development is also a big thing that we need to think about. The key is getting there together. And this is what we are doing with the European AI Week. It's getting there together so that we can actually define our priorities. And I am lucky enough today that I'm accompanied by a number of brilliant speakers that will show you what AI can be used for and what are the challenges of its adoption in a hospital using different use cases. So this inspirational workshop is the first step. We'll have another workshop later in the year where we'll invite hospital management teams to participate, and we'll guide you into adopting a mindset that you will be able to use when adopting your very first AI project. So thank you for your attention. And now I will leave the floor to our next speakers. Our next couple of speakers actually is Kevin Francois, which is the CEO of Sagacify, an AI company, which has helped us tremendously into setting up this workshop. Welcome, Kevin. And Professor Anne Jacobs from Smith VUB was also present during our moonshot on AI for health. They will talk about how AI can be transitions from idea to actually automate processes in the hospitals and what hospitals can gain by doing that. And Kevin, the floor is yours.
Thank you very much, Giovanni. Can you hear me?
Yes, very good.
How can I take control of the slides?
So I will stop the remote control and you can take back the control.
Sounds good.
So view options and request remote control. So it's on the upper side of the screen.
Yeah, there's a little. Oh, okay. So okay, I see it. Okay, cool. Thanks. Request. There you go. Do I have it? Okay, cool. Okay, thanks for the introduction. Sorry, so I don't use Zoom every day. So indeed, I'm the CEO and co-founder of Sagacify, where Sagacify is a company specialized in deploying a project and helping our customer benefiting from AI. And so we indeed specialize in helping companies identify all the the latent opportunities that are there that they could go get. All the way to the deploying production of those systems so that companies can benefit and get the value out of those systems. And so not only am I going to, this inspirational speech is a premise to the workshop that Giovanni mentioned, in which we're going to help you with a methodology that has been proven to be quite successful to identify all the opportunities within your hospitals to help improve its organization. And if it works out, then we're going to give you the keys also to benefit from it. But before I start, I'd like to start with this slide. I'm not sure in 2022 if it's still necessary. Please tell me so in the chat if you think that it's like overdue. But to clear it out, I'm going to just explain. To me, what is AI and what we need to remember is that we didn't wait for artificial intelligence to automate tasks. And if you want to automate tasks in your hospitals, chances are that you have been deploying a whole lot of programs and computer softwares to do so. But different between a computer program traditionally and artificial intelligence is that a computer program, you need to write instructions that are telling the computer what to do to execute a task. That works fine until you run into very complex tasks that either have to process so much data that you cannot identify all the possible outcomes, or because the data are semantically too complex, like images, speech, time series, text, and so forth. And Software 2.0 or artificial intelligence is being taught in a different way, as I just mentioned. Instead of writing instruction telling the computer what to do, you just teach the computer what it has to understand to be able to reproduce a task. So you don't define the rules anymore. You let it learn the rules. Voilà, that's it. And so basically you can get like, definitely we make huge use of the latest technology in the sphere of artificial intelligence, which is deep learning, which basically helps you treat and take as input any kind of signals that you might find, whether there are images, multimodal images, text, speech, time series from ECG, or open data, or all the also structured data that you might find in your hospitals. And so the opportunities are endless because all the signals that a human is treating to make his decision can potentially also be fed into an AI system to help you automate decisions or define an outcome, such as early detection of sepsis, for example, to identify pathogens or like labels in medical imagery, to identify anomalies in your hospital processes, and so forth. So you need to really keep in mind that AI is just a mathematical function that maps an input, whichever it is, to an output, which most of the time is a decision to to help you make a decision, or just simply by automating a task. And so if I want to summarize the advantages of AI, is that it can work with today semantically very complex data. So there is no limit in the kind of signal that you can use. And that opens up basically all the tasks that us as human are doing, like all the tasks relying on the perception that we do with our ears, eyes, and then our capacity to read. It can analyze a huge amount of volume in no time. Let's say that you need to analyze a whole library of scientific publication on a particular disease and all the treatment associated to it. That's a ground for personalized treatment, for example, something that no human could do. And also, all the processes that are being automated by AI are systematically very consistent and precise in their decision. There is no bias. They don't get tired. There is not the effect of one person taking a decision versus another. So in a sense, it's more deterministic. And also, it improves over time. Like, it's not because you deploy your system in production for the first time that it stops learning. So it's going to keep learning over time, improving itself. And in a way, it helps you capitalize on the knowledge that you feed to the system and improving your assets. There is a question about no bias. There is, at the end of this speech, there is sometimes for Q&A, there is definitely a lot to say about biases. So feel free to ask a question later. And so indeed, as Giovanni mentioned, if we consider on the left side of this slide, the layout of the hospital organization, you might wonder, but how can a hospital benefit from AI? So this is, I'm not going to spend too much time because I'm going to repeat what Giovanni said, but at every level of the organization of a hospital, from the patient admission to the patient journey through all the services and all the back office services that are necessary to support the operations, well, AI can help you be more efficient, reduce the costs, and in the end, help treat patients better and faster. Also, maybe I forgot to mention that Sagasify is not solely focusing on the hospital and the healthcare industry. We're multi-sectorial by nature. We've been working on more than 40 AI projects that we've been deploying in production. So we know our job extremely well. And we know what it takes to deploy a system successfully in production. So this is why we think that we can still help hospitals figure out what to do and ensuring that they're successful. And so one example here, it's an invoice anomaly detection system. So before an invoice is sent to a patient, we make sure that the invoice doesn't contain errors so that the patient is not charged uselessly or fraudulently. And also that there hasn't been any mistake in the hospital system, like forgetting a bunch of invoice that might not have been sent, that might never have been sent. And the little spike in the little red bars are correspond to the COVID outbreak in March 2020 in the system. You could see that still picked up a lot of anomalies. So this is just one tiny example of a process that you can drastically optimize so that people don't have to think about it all the time, and they can free up some time to do something else. Which is basically what my slides here is saying, is that why hospital need AI, if I want to summarize it. You can definitely free hospital staff from administrative tasks so that they have more time to focus on the patient. Obviously, you can reduce the cost, and down the line, help treat patient better and faster. There is definitely a way today to provide a new patient experience compared to the old way of doing things. And so if hospitals don't embrace those potential technologies that can contribute to creating a new patient experience, they might lag behind and create a long-lasting delay in trying to catch up if you don't start too early enough. So this sounds very interesting, like the left side of the picture, theoretically, in theory, it looks cool, but in practice, it's known to be extremely difficult to deploy in production and successfully, and also ensuring that it generates the expected value an AI system in production. And so many have tried, because everybody knows that AI techniques are powerful. Everybody knows that they need it, but also most of them who tried failed. There is a statistic saying that only 15% of companies who have tried working on AI project have actually been successful at deploying it in productions. So you need, it's not enough to just have an experienced AI team to succeed. You need this, but you need a methodology, and you need experience. And so I think that it's not, it's something to pay attention. And so I'm going to talk about some things to try to avoid that. First of all, one piece of advice: start small. So after this workshop, I'd like you to start thinking about what is potentially problematic in your organization, so that when we see each other, like in, let's say, 2 months, for example, you would already come to the workshop with precise ideas that we can discuss together. So don't waste any time to start like talking to colleagues and start some discussion groups, so that you come armed with many questions and potential. When I say start small, it's better to be successful than to be valuable if it's the first AI project that you start, because you need to create, because success will create momentum, it will create visibility, it will create buy-in into your organization, and then thanks to that buy-in, you're going to get more support to successfully embark into a series of successful AI projects. Because if you are constantly too ambitious, too soon, too complex, and if you fail, it's going to be more harder to keep going. And also start small, start fast, because if you're successful after 6 months, then after a year you have a first AI project working in production. If you start something that takes too long, well, then you're just going to take too long overall. Start small, but definitely with a long vision in mind, as the picture on the left shows. Okay, some pre-misconception. AI used to be dedicated only for the big internet giant companies who can benefit from millions of data points coming from all the visitor on their websites, which is not the case of hospitals. Hospitals have probably like only sometimes 50 or 100 data points instead of millions, as only a set of data to be able to do something interesting. Well, it used to be the case that you needed that much data. Today, it's not the case anymore. Today, we're talking more about small data, and with data-centric approach, as long as your data are of high quality, you can already extract a huge amount of value. And you could already start working with only 50 data points or 100 images, for example, if you want to build a first radiology system, for example. Also, AI used to be expensive or sometimes complicated to deploy in production. That was definitely the case a few years ago, when I just said it was like reserved only for the internet giants who had millions of data points, but also hundreds of the best AI engineers around the world. And so obviously they were able to generate a huge amount of business value out of the system. Today, we know that all hospitals combined could hugely benefit from AI. Like the economy of scale of the value that AI could bring for hospital is huge. But sometimes, due to the fact that hospitals have their own different electronic medical record system, they have their own equipment, they have their own data points, we don't have that scale. And so even if it's beneficial for all hospitals combined, implementing it at each and every hospital separately could still end up costing a lot of money. And so to prevent this, by ensuring that, as the previous slide showed, that you can collect high quality data to allow learning on smaller data, that you also put domain experts in the front line in direct collaboration with the AI experts, and you put the domain experts in control of the data and the data engineering, you can start generating a lot of value. Obviously, in terms of costs, it's by using the latest tools like MLOps platform that facilitate the transition between a POC and a production project that basically automates all the tasks that are necessary to put in place an AI project. Can you drill down the costs, reduce the costs quite a lot? And so if you combine high quality data, putting domain experts in the front as like main principal actors of a project and using the latest tools, to me, you can generate value with a smaller amount of money and a smaller amount of data. Obviously, but also there is a question I see more and more that I'm losing control of my slides there. That's the notion of federated learning. Definitely, as I mentioned, hospitals sometimes don't have a choice to build their own AI systems because interoperability of data is something that's very hard because of the dependency of the equipment and the processes and systems. But there is this notion that still, in addition to the local AI systems that are being deployed, different AI systems could collaborate cross hospitals and feed each other to improve their quality and also improve the performance. So this is something interesting that I'm curious about, is that sometimes the price is too high. If you don't have enough data, there's still this notion that you can try collaboration between hospitals to reduce the cost and increase the amount of data. A notion that's extremely important to know is that it's also like expressed by a famous British statistician, is that he said, all models are wrong, but some are useful. My interpretation of this is that no AI model will be 100% accurate. There is always a probability that it will make a mistake, just like a human would do. And so you need to integrate the fact that your AI system might be wrong into the design of your system so that it can be useful. And I'm going to explain how we do. So let's say that you're super happy, you had a POC and you build an AI model that you want to deploy in production. Depending on the case, there is always a risk linked to a decision that an AI model has made. If it's an AI model to detect whether or not there is a potential error in an invoice, nobody's going to die if it makes a mistake. And so the cost of a mistake is fairly low. And if the confidence is quite high, you can make decision. You don't need human feedback in between. On the other hand, if the cost of a mistake is very high and the confidence is low, then definitely you can't automate the decision. You need to go for human validation. And basically, as long as and you can also walk the fine line between the two and ask human feedback from time to time. So what I'm seeing here is that, voilà, you could go through full-on straight-through processing if high confidence, low error cost. But most of the time, when it touches like human, there is an impact on human. The cost of an error is very high. So you need to provide the prediction or the potential output for validation into a user interface that not only going to explain very precisely what it has found and why it made that decision, so that the human can very quickly investigate and validate whether or not the AI system made a mistake or was right. This is extremely important because not only will it feed back the human correction to the system so that the AI model can improve, but also statistically speaking, you will be able to know the true performance of the system, and hopefully you'll see it improving over time. So here, there's really a possibility, the capacity for AI models to help physician or administrative staff to only focus on the prediction that require their help, hoping that most of them will still have enough confidence to go into straight-through processing, and you'll capitalize on the knowledge because your system will keep learning thanks to that feedback, human validation and feedback loop. Also, AI models also can be smart learners, and they can also ask you specifically some data points on which they require themselves human validation because they think that they can learn something new if they present it to you. So these systems, I mean, are quite hard to figure out, but they need to be thought through from the start before starting a deployment in production. So I hope that these were a few points of reflection that but I just scratched the surface of all the discussion that we could have. What we are offering here is that to organize a workshop after this few minutes of inspiration to help you figure out on what opportunities you should work on in your hospital and try to come up with a priority list of AI projects that you could work on and try to prioritize them in a roadmap. And to do so, what we offer is to start with in the next workshop that is going to come up, a small AI introduction that goes a little bit deeper than what we did here in a few minutes, so that you get the key to understand and how to find opportunities in your hospitals. Then we're going to try with a methodology to diverge and try to think about all the possible cases and opportunities you might think of in your different hospital services. And after, explain you how we can focus and converge on all the ideas that you've got into a selected few ideas that are worth investigate deeper. And this is going to be done in collaboration with hospital experts, but also AI experts, to make sure that at the end of this morning or afternoon, you'll come out with like a roadmap of what to work on. And this could potentially take this form, is that all the IDs that are going to be prioritized will be scored, for example, according to different criterions, like what is the health value that I can create among the customer or patient experience, or how can I improve the health of my patient? How does it support also the business and operation of my hospital? How hard it is, technically speaking, to implement, and are we ready as far as like we're concerned and regarding the team internally in my hospitals, and are the patient also ready to receive maybe help from those improved system? And so those are all questions that we'll look into deeply compared to the opportunities in the project that you might be interested into. That closes my intervention. Thanks a lot for listening. Keep your IDs for the Q&A at the end. I'll be super happy to answer it. And now I'll leave the floor to Anne for the next part of this presentation.
Thank you, Kevin, for this peeking into your methodology of finding as a hospital your sweet spots to start with AI. And maybe also to give a bit of a broader vision on why we are organizing this workshop and this trajectory from the AI for Belgium Health board. It's last year we did a survey in collaboration with a specialist and with Ernst & Young. And we got some 241 replies of people working in a hospital as a CEO or a CTO or a specialist. And we also asked about how aware are you of the current state of implementation of AI today? And actually, although the people responding on this survey were already very interested and engaged into AI, they were not aware about which implementations were already done. And if they gave us some insight in the implementations that they were aware about, they were still very limited. So we found it was an opportunity to also inspire the community with what AI could do, but not only with what AI could do, but also de-risking actually to start up this kind of implementation trajectory. And we are not alone trying to tackle this big challenge. I came across a recent study, European study of different use cases in hospitals. And also here, we already discussed like which domains is application of AI welcome and necessary and urgent. And also here you can see in this diagram, diagnose, care, and logistics coming up again. But next to just focusing on the technicalities, on the which model or which AI is used, we also know from this analysis, again, that it's not enough. Just an AI model isn't enough. It needs to be embedded in a service and needs to be embedded in processes in the hospital. And for that, you need to focus also on how are we going to create a human-computer interaction which is having a good experience, which having good explainability, which engages in a right level of trust with the system that we are using. Also a big challenge, and it was already also in the chat, in the questions, is about creating this medical data space, which is aligned with GDPR, but which also enables those models to be trained and to be checked and to be validated. And last but not least, not only privacy, but ethics in general and procedures, protocols, how to deploy and enroll actually in a hospital, this kind of new systems and the changes in the processes that it's allow for. Coming back for people that saw the prior moonshot presentations, it's not only about replicating existing processes, but also seeing it as an opportunity to change processes and to create actually this change that we need in healthcare. So, pushing the buttons too quick. So, as I said, it's not only about technical challenges, and we are very aware of that as a research team. And that's also why we updated in collaboration with Vives the AI blind spot cards specifically for healthcare. And so you can see on the slides at the left are the general blind spots. And what are those blind spots? Those are things we often forget to think about when at first hand we are very positive about the opportunities that AI can bring us. And then we need to sit systematically with going through these kind of aspects to think about potential negative or unexpected implications for both patients, professionals, but also non-users of our system. And so therefore we have at one hand the general blind spots, but healthcare is of course very specific. And therefore we created also this set of cards to think through with different stakeholders, with management in the IT department, but also with the healthcare professionals about different aspects of this, these blind spots. For example, you can have, for example, the large selection blind spot card. It's about that you have this possibility of a lock-in when you just do not look into a range of technical vendors and the pros and the cons of the different solutions they are offering you and how to go about that in a systematic way. That's, for example, one of the blind spot cards the management really needs to take into account. And how did we organize it? So I gave an example here of the human versus machine. It's about control and oversight that we want about our algorithms, of course. And as you can see, there's some examples of what not to do, some examples of questions to ask. There's also a kind of template to use and to reflect on that in a systematic way. Now, for the workshop that we are organizing, we will actually reflect with Sagassify about the methodology they are already using and how we can incorporate some of these aspects also in their approach. And there are already aspects in their approach that are also part of the blind spot approach. But you can also always find it on the website to work with it independently. So I just wanted you to make aware about that tool set. So you don't need to wait until we have the second workshop lined up to take a look at it. And so, as I already mentioned, from this European use case analysis in hospital implementation, it's really also important to see it as a different step process. It's not just the modeling. And it starts very early on, or should start very early on, in a very interdisciplinary way. You need your clinicians, you need people that are very well in understanding the different user needs and trying to understand that and translate that also in a good interface, for example. And you also need a good technical team. And so in that way, with the workshop, we want to start at the very beginning of the understanding of the problem. But that, you know, after the workshop, you will not have a fully implementation plan. Then there are still steps to take afterwards. It's just to start you up and get you over a kind of risk-averse attitude to start things out, or just to feel the water, the temperature of the water. So we mentioned it a lot, and we also want to invite you already to pre-registrate if you are interested or you think your hospital will be interested to be kept up to date about this workshop initiative that will be after this workshop. So it will be really practical. We will invite you with a team of people with different background from your hospital to start do this ideation exercise with us together, and to think also about the mitigation of possible things that are not ready there to get you started with an application of AI in your hospital. So thank you very much. I give the word back to Giovanni for a Q&A, I think.
Thank you, Professor Rein Jacobs, for this presentation, and thank you, Kevin Françoise, also for this very, very nice presentation and overview on how we can use AI in hospitals from a practical point of view. Okay, so we do have a brief moment for exchanging questions and answer on the very first topic. I recall there was a question regarding bias. Kevin, you wanted to address that question.
Yes, indeed, from Bianca. So my apologies if I said that there was indeed no bias in the AI systems. What I meant is that, there is definitely de facto biases in the data, and if the biases are within the data, then the machine or the AI system will learn, regardless of the bias, to reproduce what can be observed in those data. So you indeed need to be very careful as to not transmit biases within a training data set of an AI system. Otherwise, it's going to just translate those biases that we, as a human, in our day-to-day practice, imply. What I meant also in no bias is that once an AI system is in place, it represents the collective intelligence about all the data it has been trained on. So if the data it has been trained on was the outcome of many medical experts, well, it will aggregate this knowledge and collect and basically smooth the expertise of this pool of experts, and will then be consistent from one case to another. You're going to make sure that if one day it predicted the outcome A, then the next day, if you present the same input, it's going to predict the outcome A again. There is not that person factor or medical expert factor that comes into play anymore. But I don't know if it clarifies a little bit. But indeed, you need to pay a big attention to potential biases. Yes, human biases in the data.
Thank you, Kevin, for addressing the question. I hope it sets clear the doubts that were around it. Are there any other questions for our two first speakers? There was a question regarding regulation medical devices. Yes, of course, as Kevin said, and I too in the chat, as long as a software or device that involves touching the patient or identifying the patient as such it is referred to as medical device and falls under the medical device regulation. But nowadays we have so many AI software that is represented as apps, as clinical prediction models. There are websites or even software apps in hospitals, and these need specific regulation of their own. And so this is one of the goals of the AI for Health workgroup, AI for Belgium, to push towards such kind of regulation. Okay.
I also wanted to say that there is also a huge amount of opportunities and many low-hanging fruits that you can go get in your hospitals that are not touching the patient, and then that don't require medical device regulation at all. Basically, a hospital is like any other organization. It has administrative staff, it has operation, it has logistics, it has like IT systems that are not directly touching the patient, and so you can generate a lot of value staying away from medical consideration also, which you need to keep in mind, because you can also save a lot of money, gain a lot of time, freeing up a lot of time from your staff. And as an example, the invoice anomaly detection system that we put in, that we deployed, is not impacted by that. But we're also working with doctors on like dentistry to identify like labels in the mouth, like in mouth. For this, we need to go through medical device regulation, which is a long process indeed.
Thank you, Kevin, for these additional items that will help our audience in clarifying these things. Okay, great. Now we can move on to the second part of our workshop, where we will tackle how AI can tackle a very specific part of the hospital, which we do not always think about, that is the non-clinical processes. And for this, I will introduce my two next speakers. The first is Xavier Roby, the CEO of Opal Solution, and the second one is Tom van de Putte, the CEO and co-founder of Bingly. Xavier, the floor is yours.
Thank you, Giovanni. Thank you, Kevin and Anne, as well for the nice introduction at the beginning. That was a really great introduction for all of that. So, yeah, I'm talking today about pragmatic data science for busy people, because, okay, we all know that the reality in a hospital is that, okay, most of the time we are supposed to work for the patient at the end to give him some care, while we are doctors, we are nurses or healthcare professionals in general. And yeah, we have no time actually to play with the computer and so on. So how can this computer give us some time back? This is exactly what I want to tell you a bit more. So as Giovanni told us already, as Kevin emphasized a lot as well, it's not magic all we will be talking about. It's just maths, actually. A bit more complicated maths that we did in secondary school, but still, it's just mathematics, meaning that we can understand that. And as an introduction, which is very important for all of us here, is that we know that there is a shortage of healthcare professionals right now. It has been so for years, actually, and unfortunately, it will be so till next 10 years, I think, till 2030, according to WHO, with a shortage of about 30% of healthcare professionals in Belgium and in European countries. This is an issue because, of course, this is worldwide, so there is no solution to hire someone else, but to steal this person from another hospital. So there is no structural solution for this shortage right now. But at the same time, if you look at what is the reality, and you will see directly why we were emphasizing a lot at the beginning in the introduction, why we need to unburden our staff from administrative tasks, is that actually 40% of the time of healthcare professionals in hospital in particular are used for something else but giving care. Actually, it's spending time on your computer, it's spending time with different software, with data entry and other tasks that could be somehow automate it or simplify it, from which you can even take some decision when you have the data available. And right now, at the moment, it's really a waste of the time. So it's extremely important. These numbers are from KCE in Belgium, but you have the same in other countries, in France, in Netherlands, etc. And for all of these, you should really realize that, okay, it's almost 40% of your time, so 4 persons out of 10 in the hospital that could be spared if we delocate some of the activities to who? To the computers, to the algorithms, but not only. And this is extremely important because you all know what is the most used management tool in a hospital. The one that has been spread on a worldwide basis. Okay, I don't present it, you know, it's Microsoft Excel. And this is a nightmare because Microsoft Excel, okay, it's established since 1985, so almost as old as I am. And this is a nightmare because these are spreadsheets. This is not a database. This is not a planning tool. And this is not a communication tool. Still, it has been wonderful and it's extremely practical to use, but it's at the same time what is a nightmare because it's extremely difficult to extract the data out of that in a structured way without having a lot of interactions and a lot of mistakes and errors at the end. So we will see that with some pragmatic tools that needs to be implemented quite early with interactions between the different tools that are there, you can really support your healthcare professionals to have an easier life and easier, I would say, quality of life at work. This is extremely important. So as an example, let's have a look at the workload in care units. So this is definitely human. So let's start with the end. As the previous speakers were talking about, we need to design tools that are at the service of the humans. So start with the end. It means, okay, people are extremely burdened with different tasks. There is a shortage of people working in the hospital, being nurses, being doctors. So you need to, for instance, for care units, you need to send them supports like your support team, l'équipe mobile, that will help them going there and there. If you can use the data that you have in the hospital, if you can use the different systems that you have already in place to estimate this workload, instead of just guessing and trying to communicate with all the different units as a human, you can really get the data that automatically flows to you so that you take the right decision. We were told a bit before that a lot of AI, a lot of data science is all about having support for the right decision taking. So if you have a simple interface, and was a lot emphasizing the importance of a good human computer interface. If the computer tells you quite easily, quite keenly, okay, here the situation is normal. For instance, in this screenshot, you can see one block is in green. So it means the situation is supposed to be normal out of there. Normal means, okay, possibly they don't need support. While if it goes to the orange zone, oh, there could be a bit of overwork. And in the red zone, oh, this is catastrophic. People need some support right now. You need to understand a bit more what are the different issues in this care unit. And at the same time, where are the zones where the workload is a bit lower? Having all of that, the system can provide you the data so that you as a human, you can decide what to do. As a nurse director, for instance, where do you have to help people to bring some support from interim, from équipe mobile, from students even, could be, or from the support from other teams. So this is all what you could do with practical information from different data. Once you have said that, if you collect, as we will see, other elements, you can even go towards a predictive tool, a forecasting tool for your workload, so that you don't manage just blindly, but really knowing that, okay, this afternoon, tonight, next week, maybe the workload will be like this, and you can anticipate and take the right decision at the right moment. So this is practically how you can really use your data. And this is, by the way, used via artificial intelligence, machine learning, or purely simple data science at the same time. This is extremely important. So how could you do that? First, and there are two important components. First component is something automatic, a quantitative approach that is possibly quite complicated in the way you calculate and measure your workload, but in the human interface, you need to give it back to the humans in a very simple way. Okay, you see here the arrow, it could be in the green zone, everything is fine. It could be in the blue zone, okay, it means it's a bit lighter, but it could be as well in the red zone, meaning, okay, they need some support. And there is no dark red or light red. No, red means, okay, people in this specific unit need some support. And this is thanks to the calculation that is made via your data science that you can make that. First thing, quantitative approach. But we all know that two care units are not alike. Two patients are not alike. Two doctors and two nurses are not alike. So it means that it's extremely important to have this famous feedback loop that Kevin was talking about earlier. So if you can ask your care units to say, okay, according to us as a team, this is the context. This is the feedback that we have. So when the computer says we are busy, actually we are in the green zone or orange zone or blue zone, etc., etc. And this is the combination of these two different factors that is extremely important, so that when you put all together, you have a very precise and very nice way to identify, okay, right now, this is the workload. These are the people working out there. These are the natures of the different cares and different tasks that are being done right now or will be done in my care unit, so that you can anticipate and see, okay, with all the people I have around in my team, in my hospital, I can start really now planning, doing real plannings by sending the right skill, the right people, but not only the people, but the right skill at the right time to the right location. So here I'm already out of my time to tell you about all this system. But I want to thank all the organizers, and as well to dear colleagues or companies around us, like Digital Wallonia for AI and the Analytics, that were working with us on the R&D on this project. So most of what you have seen here are already in production in different hospitals. This is real science, pragmatical science, as I said before, that helps hospitals unburden the staff and giving some quality in the work life of their healthcare professionals. Thank you to everyone.
Thank you so much, Xavier. The second part of the part of on this workshop will be given by Thomas Deput, which is the co-founder of Bingly, and we'll tackle another part of administrative burden, and that is EHR related burden given to history taking. Tom, the floor is yours.
Thank you, Giovanni, and thank you for the previous speakers to have already painted the landscape and the problem, so that saves me some minutes. Actually, what I want to focus on, it's what's on the title slide here. It's a little bit a counterintuitive message. I believe that AI can bring back empathy and the human aspect in healthcare. So we saw in Xavier's presentation that there's a huge shortage of people in healthcare, and that puts a very high burden on the time that you can spend with a patient. And of course, the time needs to be spent very efficiently, and it takes away a lot of empathy. which leads to patients who are frustrated and unhappy, but also physicians, nurses who feel that the job they have chosen when they went to university to study medicine or nursing was for this human aspect, for the social aspect. And due to the administration and the lack of time they lose, that this is draining their energy. And so at Bingley, we developed a tool that will use AI to bring back empathy. So how do we do that? Well, we looked at the thing that is extremely important in medicine, but that is very time consuming and administrative heavy. And it is the history taking, it is the anamnesis. We know that in medicine, most of the decisions in medicine are made based on information we gather by asking patients questions. And we know that this process sucks. So it can be during a consultation where a doctor will ask you, okay, what is your problem? And then will bombard the patient with very specific questions to better understand the health problem. But often patients are not prepared to these questions and they cannot answer. So it leads to frustration. Or you have situations in healthcare where it is prepared by often paper flow. So it's, you know, in 2022, even in the most advanced healthcare systems in the world, you arrive at the hospital, you get a clipboard with some papers and you get a pen and you have to fill it in. So you can imagine that these systems, even if they are extremely important, they are not very smart. So what we developed at Bingley, it's a tool that uses artificial intelligence to ask the right questions to the patient before they see the doctor or before they see a healthcare professional, a nurse, or before they go to the hospital. And this is important because we know that it frees up minimum 30% of the HCP's time. So this is already 30% you can save to spend on empathy or on other important things. Second thing that is important is by giving time to the patient to prepare the history taking, the patient can answer at their own pace, at home, at ease. They can look up information. If you ask, for example, do you take medication? If you are at home, you take the box and you can answer with the correct name of the medication with the correct dosing. So you give the chance to the patient to answer at ease, at their own pace, in their own language. And thanks to that, you get more complete, accurate, and reliable information to base your decisions upon. While we are collecting that data, we immediately structure and code the answers using, for the people who are familiar with that, SNOMED CT, ICD-10, ICPC2, so universal coding systems, which means that the data we collect, we can immediately inject it in the electronic health records in the right areas for that information. So it reduces a huge administrative burden. And so as I said, we can empower patients because we ask the questions in their own literacy, own language, at their own pace, but based on the information we collect. So we are not only an administrative tool, but we are also in the clinical reasoning. With the data we collect, we can show to the HCP actionable insights. And an actionable insight can be a triage score, can be a red flag, can be an alert, can be suggestions for screening, for preventative medicine, but can also be a differential diagnosis, for example. So how it works, you can see in this little video. So the patient will receive a link from the hospital when booking an appointment. And the only thing the patient has to type, as you can see here, is what is my problem? For example, I have stomach ache. And with that input, we will start reasoning. We will start calculating differential diagnosis, which you can see on the right-hand side in the chart. So we calculate constantly relationships between symptoms and other arguments and related diagnosis. And based on that calculation, we calculate what is the smartest question to ask the patient in order to gain accuracy in this diagnostic reasoning. And that question is presented to the patient answers, the answer is sent back to the algorithm gets updated, and a new question is calculated. So this is a completely dynamic system. And so normally there should appear the part for the doctor, but I think it's missing in the video. And so what is important here is that the collected data is sent to the doctor. And on top of that, the doctor will also see an actionable insight. So as I said, it can be a differential diagnosis, but that we only show to the doctor in order to safeguard their diagnostic freedom. And with the differential diagnosis we show to the doctor, we ask feedback. And with the feedback from the doctor, we always show 10 possible diagnoses. The doctor chooses the diagnosis. And with that feedback, we can do machine learning. But machine learning based on expert feedback. Now, asking questions using AI is great, but sometimes you don't need AI. Sometimes you can work with validated surveys or fixed questionnaires. And so what is important is that you do not have to, you don't have to overhype AI. You have to use it when it's necessary, and ideally use in medicine AI with the white box principle. So you can also show to professionals why you ask these questions or why these things are happening, so that you take away the magic or the black box thing that they are afraid of because they cannot control, they do not see what is happening inside. So I think it's important to give them the ability to look behind the screens. But it is also important that this AI is not the only solution. It needs to be able to collaborate with non-AI solutions. And so we've built what I call a medical Spotify. It's a system where as a physician or as a hospital, you can choose in what setting the AI will ask questions, or where a fixed or a validated questionnaire will ask questions, or if they can be combined, and if the AI can trigger fixed questionnaires, for example. So this is an example of a flow where AI and fixed questionnaires are used. So for example, as a patient, I want to book an appointment with, for example, an orthopedic surgeon. So I will first give some information, administrative information about myself, my insurance, for example. And then I will go through an AI history-taking anamnesis. And based on that, the doctor can see, is this patient who is booking an appointment for a knee problem with an orthopedic surgeon, is that an orthopedic problem, or maybe it's a rheumatological problem? So maybe I need to refer the patient to another center of care. But let's imagine that we confirm the appointment, the patient comes to the orthopedic surgeon, will maybe ask some extra questions, and then the surgeon decides with the patient, okay, we will do a surgery, we'll do a knee replacement. Then as a patient, I will go into the preoperative screening, which is a fixed questionnaire. But imagine that in the preoperative screening, seems that I'm taking blood thinning medication, then it needs to trigger an action in the operative flow, because then I need to follow a anticoagulantia protocol, for example. And so after the surgery, I can follow up with post-operative follow-up. And I can see, does this patient, is the healing process normal, or does this patient has maybe too much pain or bleeding after surgery? I need to come back for a post-operative consultation, or the post-operative consultation, which is normally booked after 3 or 6 weeks. It can take 3 months because everything is normal. And so what I try to explain here is that on a longitudinal or in one care pathway, you can use AI and non-AI stuff to create efficiencies in, for example, avoiding overconsumption of unnecessary visits, in reducing administrative burden, in steering automatic flows in the preoperative and postoperative stuff. But also, for example, what I think Giovanni showed, it's also the multidisciplinary approach, which is important. Which I don't show here, but for example, I saw a question in oncology. We know that in oncology, a lot of patients with cancer, they have also an increased cardiovascular risk, and some treatments in oncology are cardiotoxic. So you want to know, when I'm treating a patient for cancer, does that patient also have increased cardiovascular risk? And if yes, maybe I need to also include my colleague cardiologist in the care team. And so that's typically what AI can do based on asking patients questions which are relevant in a certain healthcare setting. So I think what is important to conclude, to bring back empathy in medicine using AI, the AI needs to be smart, but I think it's, I don't know the word in English, but it's a tautology, it's 2 times the same. But I mean smart also, it needs to be smartly thought and included in care pathways. It needs to be empowering, so patient empowering and doctor augmenting. So for example, multilinguality is an interesting aspect of that. Ideally, but that's, and what we are doing, disease agnostic, because you want this multidisciplinary and holistic approach. You want to connect the dots beyond one specific therapeutic or diagnostic area. I saw some questions about regulatory. So of course it needs to be regulatory compliant. And then there is a gray zone. Is it class 1, class 2A, etc.? So it depends a little bit on the level of decisions you are taking. Interoperability, I think that is the most complicated and the most important part if you want to successfully adopt or apply AI in hospitals. It needs to interoperate with existing EHRs, planning systems, etc. And we know that depending on the geography or the country where you are, that there are systems which are more interoperable than others. And also, if you want to learn and if you want to be multidisciplinary, all the data needs to be structured and coded at the moment that you collect the data. So you do not have to rely on NLP, for example, to do a posteriori structuring and coding. It's better to do it immediately at the source of the collection of the data. So this was my my short introduction on something that exists, that is used by hundreds of thousands of patients, that is used by thousands of doctors. So we know that we create value and that we bring back empathy using this kind of AI.
Thank you so much, Xavier and Tom, for 2 very nice presentations on how AI can be used to tackle administrative burden, but also take care of specific patient flows in healthcare. Does the audience have specific questions for this session? You are quite a lot following us on YouTube and Zoom, which is nice. So I hope that the workshop will be useful to you. The next part of our workshop will tackle a very specific care path into healthcare, and that is medical imaging. We do know that imaging is a big part of the added value of AI in healthcare, and especially the diagnostic part, but also within imaging, we can also deal with workflows and administrative tasks. And to talk to you about that, we invited Frédéric Lambrecht, which is the Chief Business Development Officer at Osimis, which is one of the leading software plugins as an app store to plug hospitals within AI for medical imaging. Frédéric, the floor is yours.
Thanks, Giovanni, for this very nice introduction. You said it well. So Osimis brings a sort of a marketplace for medical imaging AI solutions to the hospitals. This is a very down-to-earth approach, basically driven by the abundance of AI solutions that are starting to come now in medical imaging, which is one of the scenes in which AI is really picking up heavily. So I seem to be having an issue controlling, there we go, the presentation. The pressure on radiologists is ever increasing, and that's really the starting point for AI here. Meaning there's a yearly increase of about 10% of the number of medical imaging exams and the images within each exam. So the radiologists have an increasing pressure. A study showed that over the course of 15 years, radiologists that are on call have 4 times more pressure than before. And in the same time, the payback rate for medical imaging procedures keeps on reducing with about 10% year on year. And so we really grasp here why radiologists are under increasing pressure. And so AI is there to basically offer a solution to that problem. At least that is what the vendors each individually say. And we also see the number of CE marked or CE marked AI solutions that are hitting the market increasing by 60% on a yearly basis. So we see that the hospitals are being confronted with these kind of solutions, but they're also confronted with a set of very important challenges when they're trying to adopt these solutions into their clinical workspace. The first of which is vendor selection. So there's no, I would say, standard methodology for selecting a clinical use case, for identifying the right key performance indicators to track in order to monitor whether there's a return on investment. And once we've identified both the use case as well as the KPIs, well, then we still need to compare the different vendors. And so it's a daunting task in itself, basically, for a radiologist or a head of radiology to start understanding where to begin. And so they basically need a helping hand. That's the first point. Second point is data and IT integration. As we've heard today, AI is very much based on data streams, on IT technical integrations that need to be taking place. And with the number of AI solutions increasing, also each solution comes with their integration solution, which means there's a risk for data security to be breached, as well as the number of integration solutions that are being deployed in the hospitals going off whack. So that really brings a series of topics for the IT department, also data protection officers, and also data integrity within the radiology department. Then the third pillar of challenges that the radiology department really specifically is hitting is the fact that AI is good, but it can only be really good if it is very deeply integrated into the clinical workflow. That means that it shouldn't be taking more time for a radiologist to be using the AI solutions. It should be obviously the other way around, and that can only be achieved by tightly integrating the AI solutions into the workflow. That could be with the picture archiving and communication systems, so the PACS medical imaging server, or with the radiology information system, but also with the EHR, or a nice way for the radiologists to be able to mention to the AI vendor that there is a false positive or a false negative, because that's another aspect of AI that's important. It needs to be possible for the hospital and the radiologists to keep on telling the AI vendor when their solution isn't saying the right thing. They should be able to control and provide feedback to those vendors. And then there's a last pillar, which basically is a set of different items, which I could also refer to as overhead, basically. As we've seen, it's complex. So very often hospitals are appointing a project manager to an AI integration project. And then obviously this project manager is working tightly with the head of radiologists, and also the radiologists need to be briefed about the usage of a particular kind of solution. There's the data protection officer, which I mentioned earlier, also is tightly integrated into the process. The IT people we need, and also there is the buying department, the purchasing department that needs to be integrated. So there's a lot of people. We see that it will take a lot of time to integrate just a single project. And so let alone if a hospital would like to integrate 5 or 10 workflows, which is basically what it's going to be tending towards. So that is why at Osmose we have come to offer this platform-based approach, where with one single integration, the hospital can access a multitude of AI vendors. And we also act as a single trusted partner for data security matters, meaning the hospital has a frame agreement with Ausimis, and then behind the scenes, we will make sure that this agreement is being respected by the different vendors that are being integrated through the platform. We also make sure that we offer a seamless integration into the radiology workflow. As I mentioned, there's the PACS, there's the RIS, but there are also a lot of other things when it comes to integration that most radiologists don't even think about. And in doing so, it is very important that there remains a kind of neutrality. We want to bring an expert advisory role into the hospital, where we also bring a kind of a methodology for the radiologists to be able to try out solutions and basically with a plug-and-play approach, put a rational and simple integration process into place for their AI adoption strategy. So basically, there are a series of pillars where an optimized AI strategy comes into play. So the first of which is the integration technology. When you only have a single integration technology rather than multiple, you're basically running less risk in trying to integrate with third-party vendors. Also, you have one person that you need to speak to, and that's a very important element with the growth of basically the wild growth of AI solutions. Rather than having to speak to different interfaces and taking the risk of not being sure who's responsible for what. Well, you have one person who's in charge for everything that is related to integration. And then also from a radiologist's perspective, it's important that the PACS be only connected to as little resources as possible, not only for performance purposes, but also for security and for data integrity. As I mentioned earlier, there's this data and security framework agreement that needs to be managed centrally. And the last part obviously comes down to administration and billing. And so with all of that, you can basically bring down the cost of integrating AI into the workflow. I was asked to come with a very specific example of a solution that we integrate. So Gleamer is a French company that offers a solution called BoneView, and is very specifically targets bone fracture detection in standard X-rays. So the scope here is fractures, effusions, dislocations, and lesions in general. And so it covers basically all the body parts in both adults and pediatric imaging. And it is basically a CE marked solution. It may sound easy, but a certification, getting a certificate for AI nowadays is growingly complex. It's more and more structured, but there are different levels of certification. And it's important that we as a third party also basically have a sneak peek into how this certification was attained, and also what is the scientific validation that lies behind the different solutions that are out there on the market. And BoneView here in this particular case has a very good scientific track record, and it has also the right certification for it to be able to be deployed in Belgian hospitals, but also, well, in European hospitals, basically. And just to come back to the essence of this product, with this AI product, it is possible to reduce the number of missed fractures, and it's also it will also increase the reading comfort for radiologists. And so it will shorten the waiting times for patients, and it will make sure that there are less complaints, basically, of patients coming back for a missed fracture. So really, the radiologist is gaining a lot of benefits from this, but also the people in the emergency department, because they don't need to worry about disturbing the radiologist, because they need to know whether they can send the patient back home. And so basically the entire process is being smoothened by this kind of solutions. And again, this is also a solution that integrates nicely into different workflows. and that is a key aspect of what we believe is good AI. So I'm just using this as a case, as it's also been implemented already in quite a few Belgian hospitals. So if there's any will to discuss the way for hospitals to adopt AI within their departments, feel free to come and contact me.
Thank you, Frédéric, for this nice overview of how overall medical imaging is managed with AI in hospitals with the help of course, Osimis and other solutions. While the questions for the overall workshop come in the chat, I would like to very briefly have an overview of what we talked about today. So first, we started about drafting why AI is important in hospitals and why AI for health is important overall. Secondly, we drafted why AI is implemented in hospitals and what is the general workflow that Kevin and Anne presented to us. And there are some challenges that we need to look upon and most need to be thought very carefully before entering the AI game in hospitals. After that, we saw how AI can be used to diminish the administrative burden and ease the way into care pathways for hospitals. And last, we saw how AI can help automating the imaging flows in hospitals. This was the inspirational first workshop for hospitals. I'm glad that there are already several hospital management teams that have been candidates for the second workshop. Do not hesitate to put forward the registration for submitting your candidature into being accepted into the second workshop. For the second workshop, we'll accept for the first edition of the second workshop 5 hospital management teams that are willing to participate into a discussion on getting ready to build the AI project. Thanks to the help of Sagasify, Professor Anne Jacobs from VUB, and a series of other experts such as Xavier, Tom, and Frédéric that are with us today, and other experts as well. So please, if you have any questions, do ask us. If not, we will conclude the workshop. I would like to thank once again our amazing speakers of today. Thank you, Xavier, Tom, Anne, Frédéric, and Kevin for having drafted such a nice workshop. Let us keep building this community of hospitals that want to get into their first AI project. And thank you also to the technical support, Casper from Boza. Thank you for helping us in setting up the Zoom session. And thank you all to the audience. Please keep in touch and let us build a better Belgium where hospitals use AI to improve care and lives for healthcare professionals. Thank you all and have a nice afternoon.
Thank you, Giovanni. Thank you all.